This video introduces a number of routines aimed at building students' knowledge and facility with partners to 10 and 20. Throughout, we're seeking to make connections, build connections between partners to 10 and 20. We're using visual tools because we want students to create visuals in their mind that they can draw upon later on. And we're demonstrating how to represent their thinking visually. This routine, show us, tell us, is a really good lead-in to I have, you need. It also builds students' finger perception, which is really critical in terms of their mathematical development. So it starts with the teacher saying, show us 10. Show us 10 fingers. Then we say, tell us about 10. Students can say, 10 is 2 hands. What else can you tell us about 10? Well, 10 is 5 plus 5. There we've got our 5, and then we've got another 5. Someone might say, well, that's double 5. So it's just a quick chat building our knowledge about 10. Show us 5. Tell us about 5. Five is 1 hand. 5 is 2 plus 3. 5 is half of 10. Someone else might say it's 2 2s and a 1. So we've got 2 plus 2 plus 1. We could say that that's double 2 plus 1. And someone else might say that 5 is 5 less than 10. Or 10 take away 5. So we start by establishing our 10 and our 5 as our reference point or our anchors. So now we'll focus on our partners to 10. Show us 2. Tell us about 2. And students will suggest a number of ideas there. But I want to add on another aspect here, another question we can ask. How many more to 10? Or how far from 2 to 10? Or 2 plus something equals 10? So if we have 2, how many more till we get to 10? 2 plus something equals 10. And here I want to suggest that we use our anchor point of 5 for those students who do not have their rainbow facts or number partners to 10. So we have our 2, and for those students who don't have their rainbow facts or their number partners to 10 intact, we can give them this strategy of get to 5. So we've got our 2, how many more till we get to 5? And students can then work out, okay, so we've got 3 more to get to 5. And then once we get to 5, we can use that other 5 to add on to get to 10. So we've got the 2 plus 3 gets us to 5. And then we've got another 5 to get to 10. 5 plus 5 equals 10. So let's represent this thinking on a number line. So we're starting at 2. Okay, and we get the students to mark that on the number lines that they have in front of them. So we start at 2, and then we're adding 3. So we're going from 2 to 5, so we're plus 3 gets us to 5. And then we have another jump of 5 to get us to 10. So let's put this together into a number sentence. So we've got 2 plus 3 plus 5 equals 10. Or we can condense this a little bit more and say 2 plus 8 equals 10. And there's our 8 there, and there's our 8 here. We can also represent our thinking with a 10 frame and apply the same strategy, get to 5, for the students who don't have their rainbow facts of 2 plus 8 equals 10. So let's look at that. So we've got our 2, and then we want to get to 5. So we've got 3 more here. That gets us to our 5. And then how much more have we got to add? We've got our 5 here. Okay. So again, we're back to our 2 plus 3 plus 5 equals 10, or our 2 plus 8 equals 10. Let's do another example. Show us 3. Tell us about 3. It's 2 and 1, or 2 plus 1. It's 3 ones, and we can represent that 3 groups of 1. It's 2 less than 5. Then we encourage students to use their rainbow facts. How many more from 3 to 10, or how far from 3 to 10? 3 plus something equals 10. Again, you might have students who automatically know that they've got their rainbow facts intact. If they don't, let's use that strategy again of get to 5. So we have 3, get to 5. Get to 5 from 3. So we've got 2 more. That gets us to our 5. And then we've got another 5. And hopefully students have got this idea of 5 plus 5 equals 10. So let's represent this thinking on a number line. We're starting at 3, and we want to use the strategy of get to 5. So we can go from 3 plus 2 gets us to our 5, our reference point, our anchor. Then we've simply got another 5 that gets us to 10. Let's write this. 3 plus 2 plus 5 equals 10. And then ultimately we want to re-establish that rainbow fact or number partner to 10. So we have 3 plus 7 equals 10. There's our 7, 2 and our 5. There's our 7 there. That gets us to 10. Let's represent our thinking with a 10 frame. We've got our 3. 2 more gets us to our 5, our anchor point. And then we've got another 5 that gets us to 10. And we can represent it like this. We can also represent our thinking on a number path, which are a great introduction to number lines in the early years. So we start at 3 and we're getting to 5. So we're going from 3 to 5. Some students initially might count 1 by 1, and over time we want them to do the 2. Then from 5, we can just go from 5 to 10, a jump of 5. And again, we can represent it as we have up here. Let's make some connections now between our number partners to 10 and our number partners to 20. And here I want to use the routine, if I know, then I also know, or if I know, then I can work out. So if I know that 4 plus 6 equals 10, and it may be that some of the students know it from their rainbow facts or their rainbow partners to 10. Some students might need that get to 5 before they get to 10. So that would look like the 4 plus 1 gets me to 5, and then another 5 gets me to 10. So that gives us our 6 altogether. 4 plus 6 equals 10. So, but we want to then move beyond that and extend them, make connections. So if I know 4 plus 6 equals 10, then I also know, or I can also work out, 4 plus something equals 20. So here I want to suggest the strategy initially of get to 10. So we start at 4 and we want to get to 10. Okay, and we're using our initial knowledge. We've got the idea that 4 plus 6 is 10. And then we've got a jump of 10 to get us to 20. Here, students would have to have that idea of 10 plus 10 equals 20. That's a really useful fact to know here. Now, when we say get to 10 as a strategy, or when we use get to 10 as a strategy, we can also say get to a friendly number. And friendly numbers are multiples of 10. So 10, 20, 30, 40, 50, and so on. And we use those friendly numbers as we build with larger and larger numbers. So it's a handy concept to have. In terms of a sequence, I would suggest that if you are doing 4 plus 6 equals 10, and then we have the 4 plus something equals 20, then I would suggest that you do the turnaround fact. So if I know that 6 plus 4 equals 10, what about 6 plus something equals 20? So that we keep reinforcing those number partners to 10, or those rainbow facts to 10, and then we get our facts to 20 as well. So then if you did, if I know 2 and 8 equals 10, what about 2 plus something equals 20? Then we do the turnaround facts, or the commutative property. So we have our 8 plus 2 equals 10, and then 8 plus something equals 20. And that principle would apply as you get into larger and larger numbers. When you use one number, then try and use the turnaround fact or the commutative properties so that you reinforce those.